Okay, on to 10.5, we have tangents. Okay, so a tangent. Let's first look at what a secant line is. We're not going to really focus on secant lines in this chapter, but I just want you to be familiar with the terminology. So a secant is a line that intersects a circle in 2 points. So in other words, it's basically a line that contains a chord. So the chord is just the line segment versus the secant is the line. Then we have a tangent. Tangent is a line that intersects a circle at exactly 1 point. And that point is called the point of tangency. So right here, this is where we have a tangent line. So a secant cuts through the circle and a tangent just touches the circle at 1 point. So we have a theorem that says if we have a tangent line, it's going to be tangent to the circle if and only if it is perpendicular to the radius drawn to that point. So here, these have to be a right angle. So I could draw that anyway. So for example, let's take this. Here's a tangent line. If I draw to the point of tangency, if that's a right angle, then I know that line has to be tangent. Okay, BC is tangent to circle A at point C. Find the value of x. So that means this has to be a right angle. So I will have x squared plus 14 squared equals 17 squared. So we have x squared plus 196 equals 289. X squared equals 93. So x would be equal to the square root of 93. That comes out to be about 9.6. Okay. Maybe you want to try example 2 on your own. You can pause it here. I will show you how to do it as well. So QS is tangent. So this has to be a right angle. Now, this one looks a little bit different. Find the value of x. What you need to recognize, these two are radii. So they have to be congruent. So that has to be x. So I now have x squared plus 4 squared, and then this entire hypotenuse would be x plus 2. So we're going to make it x plus 2 squared. So I have x squared plus 16, and then I have to FOIL this, right? So we're thinking x plus 2 times x plus 2, so we get x squared. Outside's going to be 2x, inside's going to be 2x, so that's plus 4x plus 4. Now when I go to solve, basically the x squareds are going to cancel. Let me subtract 4x, or sorry, subtract 4, so I get 12 equals 4x. Divide by 4, we get x equals 3. Example 3 is saying determine whether it's tangent. So we're basically seeing, is this a right angle? Okay, similar to the last problem, if this is 4, then RS also has to be 4. So we're checking this triangle. So we want to see if 4 squared plus 5 squared, does that equal, what would the entire hypotenuse be? It would be 8. So I have 16 squared plus 25, or sorry, 4 squared is 16 plus 5 squared, which is 25. Does that equal 64? And hopefully you can see right away, not equal. So not tangent. Okay, we have a theorem that says if two segments from the same exterior point are tangent to a circle, they are congruent. So same exterior point, tangent to a circle, they have to be congruent. So if, almost like, you know, you can think of, right, here's a circle, almost like an ice cream cone. These two are going to be congruent. Okay. So example 5, we want to find the value of x. So even though we have two different circles here, so just looking at the first circle, or one of the circles, we know AB has to be congruent to AC. And then AC has to be congruent to AD. So by some transitive property, we know these two have to be congruent, AB and AD. So we have negative 2x plus 37 has to be equal to 6x plus 5. So we want to solve that. We get, let's see, add 2x, we get 8x. 37 minus 5 is 32. Divide both sides by 8, we get x equals 4. Okay. I'd encourage you to maybe pause it and try the next one on your own. You have two different tangents here. You can make those two equal to each other. 2x minus 3 equals 19. And then you have these two are equal. So that's going to be 3y plus 5 equals 2y plus 6. So we get 2x equals 22, x equals 11. Here we get y equals 1. All right, last example. We have the triangle is circumscribed about the circle. Want to find the value of x and the perimeter. So what you want to imagine is each of these points, okay, are different points where we have tangent lines coming from them. So for example, if we look at JO and JM, these have to be congruent, so this has to be 12. If we look at this is 7, this also has to be 7. These two are congruent. And then lastly, we have this one and this one have to be congruent because they're tangent. That means x plus 3 has to be equal to 4x minus 9. So go ahead and solve. We get x equals 4, and then substitute that back in. So actually we get this has to be 7 and this has to be 7. So in order to also find the perimeter, right, we're going to have, well, this would add up to 19. This would add up to 19, and this side would be 14. So the perimeter is 52. For homework, let's see. So for homework, we have, this is assignment number 26. We want to do page 736, 13, 14, 17, 19, 20, 21, 22, 24, 26, 27, and 41.